I want to talk about absolute value of a number. And of course, these numbers we're talking about are real numbers. The definition of absolute value, so we let A be an element of R. So A is any real number. And the way the definition is stated is that these vertical bars here is equal to this piecewise defined set over here, where A is greater than 0. And of course we'll work an example here so you get an idea of what exactly I'm talking about. Let's say, for example, something simple, the absolute value of 3. What is that? Well, if I come over here, A is greater than or equal to 0, therefore it's just A, so it would just be 3. But what if I had something like this? Now A this time happens to be less than 0, and if that's the case, then it's equal to, right, or it's got to be negative A, and A is negative 10. So we're throwing a negative out in front, and when we do that, this has to become positive 10. So whatever A is, it's going to always be the positive. If it's a negative number, then just make it positive. It's really just that simple. There's some operations with absolute value. We've got some properties. If we have something like this, remember A and B are real numbers, we're going to let n be a positive number. Of course, that's going to be with the last one that we talk about, but I was getting ahead of myself here. We can break this up as to the absolute value of A times the absolute value of B. Let's look at another one here. What if we had the absolute value of A? That is equal to A squared. Right, this is A times A. So if A were positive, then you just get a positive number, and you would take the square root of it. But in other words, we're saying that this is all equal to A. Well, how could that be? You got to go back to the properties of radicals. Right, you multiply exponents, and so you just get A. Now, if A were negative, A times A, right, it's going to be a positive number, and so we're going to be left with A again. Okay, here's another one. We can break this up. It's the absolute value of A over the absolute value of B. Now this will work only if B is not equal to 0, because you can't divide by 0. Alright, got one other here we're going to talk about. Now n is going to be a positive integer. Okay, let's work an example. Let's say n was 3, and so we'd have A times A times A. And by that first property we did, we can break this up. So if A were positive, or negative, it doesn't matter, we're still going to get A. Or if it were negative, right, we'd get the negative of it and just make it positive. So this would end up being A. Let's say A is positive, therefore I can write an A here. Okay. And then, of course, this would all be raised to the n power. But we can say this, right? And it can be all condensed down to this right here. So that's kind of a sloppy way of doing a proof there, but I think it works. There's some other properties of absolute values, some things that we need to talk about. We're going to let A and B be a real number and K is positive. Then these following properties are true: that A is less than or equal to and of course this is with our inequalities. Okay, so that's true. Something that is useful to look at. Okay, and this means if and only if. The symbol here means if and only if, and we can write it like this. About forgot that, and actually that needs to be taken care of. So if this is true, then this follows, and vice versa. Okay, let's see. We have K is less than or equal to the absolute value of A. And this is an if or an only if. K is less than or equal to A, or A is less than or equal to negative K. Alright, one other, and this one's extremely useful when proving theorems, and this is called the triangle inequality. I'll just label it as with a triangle here. This is the triangle inequality, and the way it goes is that A plus B, the absolute value, is going to always be less than or equal to the absolute value of A plus the absolute value of B. Let me say something here real quick on, let's see, whoops, went too far. Okay, on this property here and this one here, we can switch out the less than or equal to with just a less than symbol. So this is going to be switched out with a less than symbol, and it will also be true.